In this video, we're going to talk about how electric potential differences or pressures and electric currents or flow rates in light bulbs are related to each other if you connect them in series or in parallel circuits. First, we're going to talk about series circuits. In circuit activity 5, you began by building this circuit, which is 4 round bulbs, identical round bulbs, in one path, which is called a series circuit. So first of all, what did you observe when you connected the circuit? Well, when you connect the circuit, the first thing hopefully you saw is that all 4 light bulbs are lit and that they have equal brightness. How did you color code the circuit? Well, I know first of all I can start with the battery's high pressure terminal red, and I can start with the battery's low pressure terminal blue. Now, how do I do these other wires here, here, and here that are not touching the battery? Well, first of all, I want to use the fact that these light bulbs are all lit equally, so I would expect that the pressure differences across each light bulb would have to be equal. So I'm going to go from red to some color, color to color, and I need these differences to all be equal. So I'm going to say that this light bulb goes, this wire is orange, so that the difference for the top round bulb is red to orange. Then I would like to go from orange to yellow. And then I'm going to go from yellow to green. So my pressure differences are going to be red to orange, orange to yellow, yellow to green, green to blue. All those pressure differences are equal. Is the flow rate different in different parts of the circuit? Well, if I have red to orange and orange to yellow, yellow to green, green to blue, all the same pressure differences, and the light bulbs are all identical, meaning they have the same resistance. If I think of Ohm's law, the current in a light bulb would be the pressure across the light bulb divided by the resistance of the light bulb. So if all 4 light bulbs have the same pressure differences, so they all have V the same, and they all have the same resistance, then they must have the same flow rate going through the circuit. So the answer is yes. Now in the next activity, we had things changed up a little bit for us. Still a series circuit, still one path, still 4 light bulbs, but only 2 of them are round bulbs, and now we have 2 long bulbs. Let's see what happened. So when you connected the circuit, what did you observe? What you observed is kind of surprising. The round bulbs are not lit at all, and the long bulbs are brightly lit. So we really want to think about why would that be? The big question is, can the flow rate be the same everywhere in this circuit? The long bulbs are lit very brightly. Round bulbs are off, although we know there must be some flow going through them. Otherwise, how could charges be getting over to the long bulbs to light them up? So we know that there has to be some flow rate through the round bulbs, but obviously not enough to light them. Could the flow rate be the same? Is the flow rate higher in the long bulbs than it is in the round bulbs? Well, this is a really important question. And to answer that, what we would first of all do is think about, what if the flow rate wasn't the same everywhere in the circuit? What if the long bulbs had a high flow rate and the round bulbs had a very small flow rate? Now in class, we are going to specifically go through this scenario. What if the flow rate wasn't the same everywhere? Hopefully, based on our discussion in class, you would see that if the flow rate through the long bulbs was greater than through the round bulbs, that eventually the round bulbs would actually turn on and the long bulbs would turn off, which we don't see. When we connect this circuit, the way that the long bulbs are on and the round bulbs are off, and that's the way it is all the time. It never changes. So can conclude that the charge flow rate is the same everywhere in the series circuit. Even though the long bulbs are lit and the round bulbs aren't, the charge flow rate is the same everywhere in the circuit. Now you might say, well, I guess that makes sense, because if in a series circuit there's only one path and all the charges have to go through only one path, there can only be one flow rate. But what about the pressure differences? Are the pressure differences the same across all the bulbs? Well, if we say that the flow rates are the same in all the bulbs, that has implications, and the bulbs are different, have different resistances. That has implications for the pressure differences. Let's think about that. So let's think about what determines flow rates in unlike bulbs, meaning bulbs of different resistance. And to do this, let's remember Ohm's law. Ohm's law says flow rate is equal to pressure difference divided by resistance. So remember that the flow rate through a bulb is determined by the pressure difference which drives the flow, and it's also determined by the resistance which hinders movement through the bulb. So a flow rate would be determined by how much the pressure difference is across the bulb and how much its resistance is. So to have the same flow rate in both bulbs, if they have different resistances, they'd have to have different pressure differences. This little chart is going to help me understand how I could get the same flow rate in different resistance bulbs. So let's understand the chart first. I have three pressure differences, a big pressure difference, medium, small, and it shows different currents through a round bulb. Now the round bulb has a low resistance, long bulb has a high resistance. So if I put a large pressure difference across a low resistance round bulb, I'm going to have a high flow rate. If I put the same pressure difference across a higher resistance long bulb, I'm going to have less flow rate. Notice also with a medium pressure difference through the round bulb, I'm going to have a lower flow rate. So if I decrease the pressure, I'm going to have less flow. Same thing true for the long bulb. So if I go from large to medium pressure, I'm going to have reduced flow rate. But notice when I compare this way, I can see the flow rate from the long bulb for a given pressure is always less. So when I go this way on the chart, I'm always getting less flow rate because the long bulb has a higher resistance. If I go this way on the chart, I also decrease the flow rate because I have less pressure difference. Now, in the series circuits that we're working with, we just said that when I put the bulbs in a series circuit, I get the same flow rate. The flow rates will be the same in all the bulbs, even if they have different resistances. This chart will show me what I need to do. So if I have a flow rate, let's say, of 2 arrow tails, in the round bulb, 2 arrow tails needs a medium pressure. But in a long bulb, 2 arrow tails needs a large pressure. So what this is telling me is if you have a high resistance, you need a higher pressure difference, larger pressure difference, to produce the same flow rate as you get through a lower resistance round bulb. So if I have 1 arrow tail, to get a 1 arrow tail flow rate in a round bulb, I only need a small pressure difference. But to get a 1 arrow tail flow rate through a long bulb, I need a medium pressure difference. So bottom line here, different pressure differences are required to get the same flow rate in a series circuit in unlike bulbs or different resistances. So there must be more pressure difference across the long bulb than across the round bulb in order for the flow rates to be equal. Since the long bulb has a higher resistance, you have to push harder to get the same flow rate. In a round bulb which has a lower resistance, you don't have to push as hard. You need less pressure difference to get the same flow rate. So to summarize, and this is called series voltage division is the science name for this. To summarize, how do pressure differences divide up in a series circuit? Bulbs in series share the total pressure difference provided by the battery. So what we mean by that is, if the total pressure difference provided by the battery is red to blue, that's the full pressure difference of the battery, that could equal red to orange plus orange to yellow plus yellow to green plus green to blue. So a red to blue total pressure from the battery could have, when we had the 4 round light bulbs, one light bulb had red to orange, the other light bulb had orange to yellow, the other light bulb had yellow to green, and the final light bulb had green to blue. So the red to blue divides up into steps, but the sum of the steps added together equals the total pressure of the battery. Series bulbs with more resistance, like long bulbs, get more pressure difference because it's harder to get charges through them. And series bulbs with less resistance, like the round bulbs, get less pressure difference across them because it's easier to get charges through them. So here is the summary for series circuits taken from our reference tables. In a series circuit, the charge flow rate is the same everywhere. The 1s, 2s, and 3s here refer to resistors or light bulbs. So if there were 3 light bulbs in a circuit, we would say the flow rate is the same in all 3 light bulbs as it is coming through the battery. Pressures, represented by V, the pressures divide up. So if V is the pressure of the battery, like red to blue, then some of that pressure goes across one light bulb, some of that pressure goes across the other light bulb, some of that pressure goes across the third light bulb. So we wrote it something like this. We would say that red to blue might equal red to orange plus orange to green plus green to blue. The pressure of the battery gets divided up among the resistors. The sum of the pressure across the individual resistors must add up to the pressure of the battery. But the flow rate is the same everywhere. And then finally, we had the equivalent resistance of resistors in series. You just add up the individual resistances to get the equivalent resistance because there is only one path. So that's how pressure, flow rate, and resistance are related in series circuits.